Okay, so here is our lecture video for section 6.6, Rational Exponents. And by rational exponent, I just mean we're going to start seeing fractions come up as exponents, and there's a few different properties about fractions that actually make simplifying exponents a lot easier. So our first little bit here, rational exponents and radicals. Fractional exponents behave as integral exponents. All this little bullet point means is that they follow the same rules, the same exponent rules that we've been using for a while now. So an example, say we have b to the 1/2 power, and we were to square that, it just becomes b to the 1/2 times b to the 1/2, and we know if we're multiplying the same base, we can add the exponents together, and we know that 1/2 plus 1/2 is 1, and anything raised to the first power is just b. So basically what all of this little math here is saying is that b to the 1/2 is the same as the square root of b, because b to the 1/2 is a number with a square equal to b, so b to the 1/2 equals the square root of b. So basically, fractions and exponents change to roots. 1/2, we're going to be taking the square root, and it all goes based off of that denominator right there. So let's take a peek at this right here, the formal definition. For any real number b and any positive integer n, b to the 1/nth power is just the nth root of b. So basically, the denominator of our fraction goes to the outside of our root. If that n is a 2, it's going to be a square root. If it's a 3, it's going to be a cubed root, so on and so forth. And we can kind of see that in our examples right here. And it works with complex numbers as well. So let's just try a few examples with this, see if we can go back and forth. We're just going to simplify, write x to the 1/6 in radical form. If I say radical form, I want it to have a root sign in it, a radical sign in it. So x to the 1/6, that denominator is going to go on the outside. So that little 6 will go like in our little check mark of the radical. And then we have x. That's all you have to do. That's how you would write that in radical form. And then going backwards, if we're given in radical form and we want to write in exponential form, well, we have our 4 and our check mark right there, which means it's actually going to be z to the 1/4 power. So whatever is inside that check mark or in the denominator of the fraction and the exponent, that's what goes inside our little radical sign, or that's what the denominator is. It kind of just goes back and forth. You just have to work with both. So just to make sure we get this, why don't you guys try these examples on your own. Pause the video and try these on your own. All right, so 1a, right? A to the 1/5 power in radical form. Well, I see I have a 5 in my denominator right there, so I'm going to put it in my little radical sign. The 5 goes on the outside, inside the little check mark. We're taking the 5th root, and a goes on the inside. Going over to 1b, write the 8th root of c in exponential form. Well, I know that 8's going to go in the denominator of my fraction, so this is going to be c to the 1/8 power. And 1c, this gets a little bit trickier. We know the 4 is going to go outside, but the numerator is going to stay inside our radical sign. So write d to the 7/4 power in radical form. Well, we set it up like we would be trying to write in radical form. We know the denominator goes to the outside. We'll have the d on the inside, but this numerator right here stays inside as well. So whenever we have a fraction that's not 1 over something, the denominator goes on the outside, the numerator stays on the inside. Same idea for 1d here. We're okay with a negative exponent right now. 3's on the outside, so it's going to be the denominator. Negative 5's on the inside, so it's going to be the numerator. So this is just c to the -5 over 3. And that's how we'll go back and forth between the two different types of forms. Again, numerator inside, denominator outside. Maybe write that down in your notes. Numerator, which is the top, inside, denominator, which is the bottom, outside. And we're really going to use that to kind of go back and forth between the two different types of forms. So now let's talk about simplifying expressions. And these rational exponents make it a little bit easier. Oops, a little blurry there. There we go. Okay, so whenever we have a negative exponent, we knew back when we were just using whole number integer exponents that a negative exponent puts it in the denominator of a fraction. So I can actually rewrite this as 1 over 81 to the 1/4 power. Because I know that negative exponent puts it in the denominator of a fraction, that's back to our basic exponent rules we've been using all year. And what we've learned in the past sections is that we can't have a radical or root on the bottom of a fraction. That's where we had to rationalize the denominator. So looking at this is just 1 over the 4th root of 81, since I know that since the 4 is in the denominator of that exponent, it goes in the outside of our radical sign. And before we get into seeing if we have to rationalize this denominator, let's go ahead and check to make sure that this isn't a whole number. All right, I don't know all my 4th roots off the top of my head, so I'm going to get out my calculator. And I could guess and check and be like, okay, so 2 to the 4th is 16, 3 to the 4th is 81. That's the number I had here, so I know that this is just 3. So this is really just 1 over 3. And we would be done. But if I didn't want to guess and check, I could come to my calculator. I could go to my math button and see that I can use my radical sign there. So I go back to my home screen. I want the 4th root, so I'll put 4 out in front. I'll arrow down to my little radical sign right here, and then of 81. And I get 3 as well. So that's another way that you could do it. And that would be how we could simplify that. So then over here, looking at part B, we have 2/16 to the 2/3 power. Well, if I rewrite that in radical form, I know the 3 is going to go on the outside because it's in the denominator. I have 2/16 squared. Well, if I want to clean this up a little bit, 2/16 squared is, I could type that into my calculator. I don't know it off the top of my head. 2/16 squared is that. So we have 46656, and I really don't know that cubed root off the top of my head, so I'm going to go to my math button, arrow down to my cubed root, type that number in to get to my final answer. It's 36. Your calculator is going to make this way easier in the long run, so if you guys know how to use that, it's going to really come in hand. So we'll keep moving on. Why don't you guys go ahead and try this on your own. Pause the video and try this on your own. Okay, so I have a negative exponent here, so I'm going to go ahead and make this a fraction and make it 1 over negative 3125 to the 1/5 power. Well, I know this 1/5 power is just actually the 5th root, so this is just 1 over the radical with our 5 on the outside, negative 3125 on the inside. Again, I don't know that off the top of my head, so I'm going to use my calculator again, go to my math button. We're taking the 5th root, so I want to do 5 math down to get that root radical sign there. Negative 3125 to get that my final answer is negative 5 for that denominator, which means my final answer is just negative 1/5. So again, sometimes these fractions just make simplifying a little bit easier. Looking at 2b, the 8's going to go on the outside because it's in the denominator. And then we have 256 cubed. So then figuring out what 256 cubed is, I'll use my calculator here. It's a pretty long number. So we have the 8th root of 167777216. Pretty long number there, but it's all good. Again, I don't know what that is off the top of my head, so let's keep using our calculator. I know I'm going to take the 8th root here, so I'm going to do 8, my math button, down to my radical sign, and then I'm going to select that past answer, and boom. My final answer is 8. So not too bad. We're just going from radical form to exponential form, back and forth a little bit, and sometimes one's easier to solve than the other. So all of this work we've been doing creates this general definition, and basically we come up with this formula right here. So for any real non-zero number b and any integers x and y, if we're given b to the xy power, and we split it up using our rule we just learned, it actually just becomes this. This is more of a shortcut. If you remember it, great. If not, we can do exactly what we've been doing when we're simplifying here. So we're going to keep moving forward. And we're going to talk about simplifying expressions. So all the properties of powers covered in section 6.1 still apply. So everything we've been doing so far in chapter 6, they all still apply. We still have to be thinking about all those rules. If I remember correctly, we had a list of rules we had to think about. And then any exponents in the denominator of a fraction must be a positive integer. So this is the big one right here. We can't have a fraction exponent in the denominator because that's the same as having like a square root in the denominator. We know we can't do that, and we're still going to have to rationalize the denominator. I kind of mentioned this before, but now we're going to kind of get into that. So let's take a look at an example using some different exponent rules. Right here, we're multiplying two numbers that have the same base. They both have the same base a, which means that we can just add those exponents. And when I add those exponents, I get, okay, well, 4 plus 2 is, I get a to the 6/7. And that's all I can do. That's as simplified as it can go. So that's just remembering our exponent rules from what seems like forever ago. Now, when we have a negative fractional exponent, that's when it gets a little bit trickier. So right away, I'm going to go ahead and rewrite this, knowing that this just moves this whole term to the denominator of a fraction. So this is really just 1 over b to the 5/6. And when I want to rationalize this, I basically want to make this fraction a whole number. So since our denominator is 6, I want to end up making it 6/6, so it just becomes 1, which means I need one more sixth, because 5/6 plus 1/6 equals 6/6. And so since I want that 1/6, I'm going to rationalize this by multiplying the top and bottom by b to the 1/6 power. Because when I do this, and I multiply across, well, 1 times b to the 1/6 is just b to the 1/6. This right here is just like I did in this last example. I can add these two fractions together. 5/6 plus 1/6 is 6/6. Well, this right here is just b to the first power. It's just b. It's just 1. It's just b. So this becomes b to the 1/6 over b. And this would be our simplified answer. So again, your goal is to get this bottom of your fraction, this denominator, to be a whole number. Whether it be 1, 2, or 3, your goal is to get it to be a whole number. And that's how you decide what to multiply by. More times than not, you're just going to multiply by 1 over 6, whatever the fraction is, 1 over the same denominator. So why don't you guys go ahead and pause the video and try those two on your own. Okay, for A, well, we have the same base here, so we're multiplying, so we can add these exponents together to get p to the 1 plus 9 is 10 over 4. And I do always want to reduce those fractions. Let focus here. And 10 over 4, those are both divisible by 2. So this is actually p to the 5 over 2. And that's as simplified as I can make that one. This is just like the second part of the last example we just did. I'm going to start by getting rid of that negative exponent by putting it in the denominator. Then I see, okay, to make this a whole number, I'm 1 away from making this 5 over 5. So I'm going to multiply the top and the bottom by r to the 1/5 power. I'll multiply across to get r to the 1/5 in my numerator. And then right here, I get to add those exponents, 4 plus 1. This becomes r to the 5 over 5. And cleaning this up a little bit, I get r to the 1/5 over r, because this just simplifies to be 1. So we have r to the 1st power in our denominator. So hopefully you guys are kind of see that pattern right there. That's what's going to happen more often than not whenever you have those. So keep moving forward. We're going to beef it up a little bit, making it a little bit harder. So now we have one of these guys, where before we would just multiply the top and the bottom by the square root of 3. But if we think about that, we can't combine a 4th root and a square root together, so it's not going to get us very far. So let's use these fractional exponents to our advantage. So I'm going to go ahead and rewrite this using fractions instead. So I have 27 to the 1/4 power, 3 to the 1/2 power, and from here, let's see if I can break it down any more. And I'm looking at the 27. I got to think to myself, okay, is 27 a perfect root? I know it's not a perfect square root, it's not a perfect square, but 27 is 3 cubed. So I'm going to break this down more. Well, 27 is 3 cubed to the 1/4 power, still over 3 to the 1/2 power. Well, I know because of my exponent rules that we've been using a lot that I can just multiply these guys together to get 3 to the 3/4 power altogether over 3 to the 1/2 power. And now, if you guys remember way back when we have the same base, which we do now, 3, we got to the same base, we can subtract our exponents. So I can subtract these exponents here, and 3/4 minus 1/2 is going to leave me with 3 to the 1/4 power. And since we started in radical form, I'm going to end in radical form. So I know the 4 goes on the outside because it's in the denominator. 3 goes inside my radical sign. And that will be my final answer. And now using those fractions, we're doing a lot more just multiplying and adding, which makes simplifying a lot easier. So let's take a look at part B over here. This one's a little bit trickier. The first thing I'm going to do is I'm going to write this using fractions instead. So this is really just 64 z to the 6th power, all raised to the 1/3 power. And kind of looking at what I have, 64, I can probably break that down a little bit. I know 64 is just 8 times 8, so that's just 8 squared times z to the 6th power, all to the 1/3 power. And just like I did in the last example, I'm going to distribute that 1/3 to both those exponents there and just get that this is 8 to the 2/3 power, z to the 6 over 3. And then just cleaning this up a little bit, 8 to the 2/3 can't really do much with that now, but 6 divided by 3 is just 2, so that's just z squared. And I have a few options here. I could just plug this into my calculator, this 8 to the 2/3, and see what it is. Or I can say, okay, well, this is really just the cubed root of 8 squared, if you think about it. So I could split it up and do it that way, or I could just type it into my calculator and say, well, 8 to the 2/3 power is just 4. So my final answer is 4z squared. And that's how you can use your calculator to your advantage there. Yeah. So then, moving forward, we have one more example to get through. Same idea, we're still just simplifying here. And these are our harder ones because we have an expression at the bottom that includes a addition sign right here. So when we're rationalizing this denominator here, this is when we multiply the top and the bottom by this expression and we just change this sign. So it changes from an addition sign to a subtraction sign. We multiply top and bottom by the same thing, and we're going to end up foiling. So this is definitely the hard examples here. So if we FOIL this out, we have our first, so this is going to be 3x to the, I can add these exponents together. 1/2 plus 1/2 is just 1. We have our outside, so this is going to be minus 2x to the 1/2. Our insides, minus 6x to the 1/2. Our last, -2 times -2 is a positive 4. And then down here, our first, we have 9x to, again, 1/2 plus 1/2 is just 1. We have our outside, so then minus 6x to the 1/2. Insides plus 6x to the 1/2. Remember, that's what we want to happen. And then minus 4. So we clean this up a little bit. And we have 3x minus, well, this, -2 minus 6, since they both have the same exponent here, we can do minus 8x to the 1/2 plus 4. This is just 9x. These cancel, minus 4. And this is actually all we can do. So that really wasn't that bad. As long as we don't have an exponent as a fraction in our denominator, we are good to go. And to wrap up this lesson, I have this little chart for you guys, and you guys can use this as a checklist of, am I simplified enough? There's no negative exponents, we're good. It has no exponents that are not positive integers in the denominator, no fraction exponents, it's not a complex fraction, we're good to go. The index of any remaining radical is the least number possible. We can't break down the radicals anymore using all those rules we learned earlier in the chapter. So use this checklist to see, like, am I done when you're working on your homework. So page 425, number 2 through 14 evens. The problems will also be posted on Classroom. Email me if you have any questions.